Hello, dear all. Today we are going to talk about the very first module that we have got in communication theory. Okay, so communication theory, just to give a brief idea about it, it's all about the analog communication. We all know that basically there exist two different types of communication system. One is analog communication system, and then is the digital communication system. The only difference is the kind of input what we give to the system. If we are dealing in terms of analog signals alone, we call the entire communication system to be analog communication system, else it becomes a digital communication system. So in communication theory or principles of communication system, what is in general, uh, the title is, we'll be talking more about the different modulation techniques, the noise which gets added to the system at the receiver, and the different digitization techniques and all those things. So this is a brief idea about the communication system. So coming to the first module, which speaks about the amplitude modulation, the best book that we can refer to this is Communication Systems by Simon Higgins and Moher, 5th edition, John Ville India Private Limited, 2010 edition. Okay, so what are the different elements of a communication system? So, any communication, if we have to talk about the definition of a communication system, it is a process of conveying or transferring information from one point to another, or it is basically a process to establish connection or link between two points for information exchange. Okay, so any communication system can be represented in general as shown in the block diagram. If you see, anyways, we require an information source. We also require a transmitter. A channel is required. A channel can be wired or wireless. This is where the problem arises. The noise gets added, be it a channel wireless or a wired communication. Noise will always get interfered, and we have the receiver, and finally the information reaches the destination. Okay, so this is a very generalized block diagram. So I hope this is clear to you, the definition as well as the block diagram. Okay. So coming to the information source, what it is, the message or information to be communicated originates in information source. Message can be word, group or words, code, data, symbols, signals, etc. What is a transmitter? The objective of the transmitter block is to collect the incoming signals, message signals, and modify it in a suitable way such that it can be transmitted via a chosen channel to the receiving point. This is the whole idea behind a communication system. Okay, a transmitter basically. Coming to the channel, channel is basically the medium. It could be a physical medium or it could be a wireless as such. Here we are referring to a physical medium to initially have the basic idea about the channel which connects the transmitter with that of a receiver. The physical medium could be copper wire, it could be a coaxial cable, it could be a waveguide, it could be a free space or an atmosphere. Okay, what is a receiver? Receiver block receives the incoming modified version of the message signal from the channel and processes it to recreate the original form of the message signal. Okay, what is a signal? A signal is a physical quantity which varies with respect to time or space or independent or dependent variable, which is normally a time. Okay, an independent variable is normally a time. It is electrical waveform which carries the information. For example, if you consider m of t, considering m of t to be a message signal, it can be represented as a cos omega t plus phi, where a is the amplitude or peak amplitude, and w is the, or omega is the frequency normally represented in radians per second, and phi is the phase angle, which is again a problem in our communication. Whenever there is a phase getting inserted to the actual signal, there occurs a lot of problem. Okay, so moving on to the next, what are the basic two different types of signals? Understanding this is also important. There are two different types of signals. One is analog or continuous signal. Second one is a digital signal. What is an analog or a continuous signal? If the amplitude of the signal continuously varies with respect to time or if the signal contains infinitely many number of amplitudes, it is called an analog or a continuous time as well as voltage signal. What is a digital signal? A digital signal is one wherein which contains only two discrete amplitudes, which could be a high or a low, or it could be in terms of TTL if I say +5 and 0 volts. With respect to the communication, signals are classified into two. One is baseband signal, other one is a band pass signal. What is a baseband signal? If the signal contains zero frequency or near to zero frequency, it is called as a baseband signal. The best example is a voice signal. So normally when we say voice or audio signal, we say that the frequency ranges somewhere from 0 Hz to 20 kHz. That's the audio frequency range. But a voice frequency range will start from very near to zero value, which is around 200 or 300 Hz, and goes up till around 3.4 kHz, or max to max I can say 4 kHz. So you can just see the frequency ranging very nearing to zero. So those kind of signals are called baseband signals. So it is always our assumption that the input signal what we give is a baseband signal, which is kind of untouched signal as it is, unprocessed signal. Okay, it could also be biomedical signals and lot many things. Okay, so coming to the bandpass signal, it contains a band of frequencies far away from base or zero, and such a signal is called a bandpass signal. Examples could be AM signal itself. And after the modulation, whatever the signal we get, we say it is a bandpass signal. But this doesn't mean that the input signal need not be a bandpass, or it should not be a bandpass. Even an input signal what you give to a communication system can also be a bandpass signal, which contains a band of frequencies. The example which I gave just now for a voice signal ranging from 300 Hz to 3.4 kHz. If you take some other signal which is, say starting from 4 kHz and goes up till 16 kHz, that also becomes a bandpass signal, but it is a little bit far away from the zero frequency value. Okay, what is a message? It is basically a sequence of symbols. Example, you can just type a message called Happy New Year. We have been doing all these things since we started using the mobile phone. Even in when we try to message using a email, we do it. So such a kind of thing is what is message. What is the information? Whatever the content that is there in the message is what is called as a information. It is basically inversely proportional to the probability of the occurrence of the symbol. Okay, so this point is quite important, but for the analog communication part, this may not be more important for us, but still as a basic we can discuss about it. Information is measured in bits, decits, or nats. These are normally few units that we can use for the measurement purpose. Okay, what are the limitations of a communication system? So there are many. To name few, there is one technological problem. That is, to implement a communication system, transmitter, receiver, and channels are always required, which requires hardware. And the communication system obviously becomes more expensive, and it will also be complex depending on what kind of signals we are dealing with and what is the distance between the transmission as well as the reception entities. Second thing is the bandwidth and noise. Very, very important thing. The effect of noise can be reduced by providing more bandwidth to stations, but due to this, less number of stations can only be occupied. One best example that I can give is, all of us are aware of the FM channel. It ranges between 88 megahertz to 108 megahertz. So when you try to see too many number of channels, obviously the bandwidth is going to come down. So whenever I'm talking about bandwidth, we basically allocate certain center frequencies and try to give certain band of frequencies to each channel. So if you have to increase the number of channels, obviously you will have to reduce the bandwidth. If you are reducing the bandwidth, obviously noise creeps in. So there is always a trade-off between the bandwidth as well as the noise. So noise doesn't mean that some external signal comes in and basically adds to the signal. It could also be a useful signal which is present next to the actual signal, which will create an interference that also becomes a noise. Coming to the signal to noise ratio, which is the third limitation in a communication system, noise should always be low to increase the channel capacity, but it is again an unavoidable quantity in any communication system, because that's kind of naturally existing one which can never be eliminated completely, but it can be suppressed to a certain extent depending on how we are going to design the communication system. So now comes our actual topic, which is about modulation. What is the meaning of modulation? Modulation is basically a process of varying the characteristics of the high frequency carrier in accordance with the instantaneous value of the modulating or the message signals. Now when I say characteristics of a high frequency carrier, characteristics could be amplitude, frequency, or phase. So based on the change in the instantaneous value, I mean to say the amplitude of the modulating signal, you start varying the characteristics, which means frequency or phase or amplitude. Such a kind of thing is what is termed as modulation. Now, there is a point to understand here. We are specifically quoting about the carrier which has a high frequency. Now, why do we have to use a high frequency? I can give a small example. Okay, uh, if a rocket has to be launched to moon, let us say, can we think of sending a kind of bicycle equivalent power uh, to carry the satellite? Obviously that is not possible, correct? You require an entity which has more power, correct? Only then it can carry the satellite. In the same way, if there is a message signal which is equivalent to a satellite, if the message signal has to get carried properly from the transmitter side to the receiver side, you would require a signal which is having more strength. Now, strength is spoken in terms of the frequency here, because higher the frequency, lesser is it prone to noise. So that is why we think of always a high frequency carrier whose characteristics will be changed based upon the amplitude of the modulating signal. Or in the other way, it can also be defined as it is a frequency translation technique which converts baseband or low frequency signal to a bandpass or a high frequency signal. Modulation is basically used in the transmitter. So obviously, the reverse of this is done at the receiver, which is demodulation. Okay. Coming to the different types of modulation, there are two different types of basic modulation. One is called a continuous wave, other one is called the pulse modulation. In continuous wave, which is right now our interest of discussion, one is amplitude modulation, other one is angle modulation. In angle modulation, there are again two different types, which is frequency modulation as well as phase modulation. So in our syllabus, we'll be dealing with amplitude as well as the frequency modulation. So only one of the angle modulation technique will be referred in this discussion. So coming to the second kind, which is pulse modulation, there are two different types again. We again talk about the analog modulation, other one becomes the digital modulation. So we basically use pulse as the carrier in pulse modulation. So under the analog modulation, which is again under pulse modulation, there are three different types: PAM, PWM and PPM. PAM stands for pulse amplitude modulation, PWM for pulse width modulation, PPM for pulse position modulation. Coming to the digital modulation, there are different things like many more things are going to come, but we have listed out only two here. Pulse code modulation, the extension of that is what is called the delta modulation, and then adaptive delta, all those things are going to come. So we'll talk about the basic continuous signal modulation, the one which was told here, the continuous wave modulation, wherein we have got amplitude as well as angle modulation. So what is amplitude modulation? The amplitude of the carrier is varied in accordance with the instantaneous values of the modulating signal. Okay. So what is frequency modulation? Now these are the characteristics that we are talking about the carrier, whose values will get changed based on the amplitude of the modulating signal. So frequency modulation of the carrier is basically a frequency modulation is change in the frequency of the carrier in accordance with the instantaneous value of modulating signal. Likewise, phase modulation is varying the phase of the carrier in accordance with the instantaneous value of the modulating signal. What are the benefits or needs of need for modulation? Because we are doing modulation, we are investing a lot, and we are trying to understand many things about modulation. So, what are the benefits of modulation? Number one, it will reduce the length or height of the antenna. We all know that the height of the antenna is proportional to lambda by 4. So as and when the frequency reduces, you see that the lambda value grows, which means you'll have to increase the height of the antenna so that you can make that signal reach the destination. So as a low frequency signal, if you try to transmit as it is, you would require an antenna of kilometers height. Okay, as an example, if I say I have a 1 hertz signal, okay, a 1 hertz frequency signal, then what will be the lambda value? We all know V is equal to F lambda. So F V lambda basically becomes equal to V, because F is equal to 1, which is 3 into 10 raised to 8. So you would require such a height of, such a height antenna to transmit a 1 hertz, frequency signal. So that's the first and foremost benefit of a modulation, because the moment I do a modulation, high frequency obviously comes into picture. High frequency would reduce the antenna height. Second thing is, it avoids mixing of signals. Suppose if I have many signals together, and if I have to transmit it all together, let us say three people are talking together, and all three people would like to transmit their signals as it is without modulation. And just now, in the beginning, I mentioned about the bandwidth of voice signal. It will be ranging between 300 to 3.4 kilohertz. So everybody's voice signal will be within this itself. It may have different frequency components, but the range is all the same. So when you try to transmit it over a, let's say, the space, obviously all the signals will get mixed up, because they can always combine together, and they can form a new signal which becomes a voice noise signal for us. Third advantage is increase in the range of communication. So obviously there is a, we can send the signal over a longer distance. Fourth one is, it allows multiplexing of signals, which is the most important application of modulation. Fifth one is, we can adjust the bandwidth also. This we shall see in the later part. And it also improves the quality of reception, because as I said, high frequencies are less prone to noise, so it has an advantage. So in that way, we'll be able to gain a lot of benefits by going for modulation. I hope you have understood till this point what and all we have discussed. Coming to the very first kind of modulation technique, which is our, the sole purpose of this module is to talk more about amplitude modulation. We already have, given the definition of this. Now we can see some, waveforms and all those things to understand in a better way. The amplitude of the carrier is going to vary in accordance with the instantaneous amplitude of the modulating signal. So that you can see two different types of signals here. One is your baseband, which is also called a message signal, or you can also call it as a information signal. So that's the input signal which you have to transmit. As an example, we have taken a simple sine wave. It could also be a complex wave which contains many tones or many frequencies within it. And there is a carrier signal, and obviously you can make out the difference between the baseband and the carrier. Carrier frequency is more. Okay. So, and this is how the modulated wave will look like. Okay. And what is the equation? So if I try to say that the carrier signal is indicated as C of t, which is equal to AC cos omega ct, where AC is the maximum amplitude of the carrier signal, and omega c is nothing but 2 pi fc, which is the angular frequency of the carrier signal. And if you also assume that you have a baseband signal indicated as x of t, which can be written as am cos omega mt, where am is the maximum amplitude of the baseband signal and omega m is your angular frequency of the modulating signal. So we can write the standard equation of the amplitude modulated wave, where you can observe only the amplitude of the carrier is getting changed. So we can write S of t, which indicates the modulated wave, as AC into 1 plus m times of cos omega mt whole multiplied by cos omega ct, where we can say MA, which is nothing but the modulation index, as AM by AC. This parameter is very, very important, because it will tell us how basically we are performing the modulation, whether it is under modulation, critical modulation, or over modulation. We shall see in the later part of the discussion. So now we'll try to understand the time domain representation of the AM signal. So probably in the next video, we shall try to cover up this AM part. Okay, thank you.